Hi, my name is Ken, and this is Let's Code a Mud in C++11 Part 10. So in the last part, we started some connection closing logic, and we got to the point where the connection reader can close a connection if it detects an error, like the client closed its side of the connection, or maybe in some case if it detects like a quit command or something, it can call this done reading function that we wrote. That tells the base class to go ahead and finish up any writes and then to terminate itself. What we didn't do was to make it so that the server could tell the connection to close itself. And that's what we're going to do in this part. And also we're going to do a couple other cleanup things in the server class or in the server component as a whole. Because my goal for this part is once we're done with this to have basically a functioning server, something that's memory safe, that reads, writes, closes connections, and that we can more or less leave alone and start to move on and start to look at the things that make this mud-like, to do logic, grammar, parsing, commands, that kind of thing. And really get to coding a mud in C++11, not just a server in C++11. Although we will come back to the server here or there to talk about a couple things. But so let's do that. Let's get that done in this part, and then we can move on in the next part. So the first thing is to make it so this server can shut down. So let's look at the server class. And right now, what we have to quit the program, we have a signal handler. We have something that listens for sigint or sigterm, like a control C on the console, and it cancels the acceptor. And if that's the only asynchronous task outstanding, then the IO service will return, and the program will quit. And that works if there's no current connections out there. However, it doesn't work if there are connections out there, because they're doing async writes, async reads. There's never going to be a time, at least, that it's not doing an async read. So the program will never terminate as long as there's an active connection. So we need to fix that. So what I want to do is I want to make a distinct shutdown method that the outside program can call. And so that's going to do all these closing and canceling operations. We'll move those in here. One thing we'll have to do is we'll also have to cancel the signal set, because it might not be the signal set causing the shutdown. It might be something else causing the shutdown, in which case the signal set's async wait is still out there and has to get canceled. So put that shutdown in here. And if the signal set does get canceled, we want to make sure that it doesn't actually do this, that there's only one shutdown call. So let's say if error not equal boost ASIO error operation aborted. Okay. So if it's any other error, or if it's no error at all, if it's a successful async wait, we'll go ahead and cause a shutdown. All right. So that works. That gets us to our status quo, to where we are right now. But we also want to cancel out the connections. We want to close the connections. And so for that, we want to do a for loop. Right, we want to do a for loop for all the connections. Do connection.close. So what's this for loop look like? In C++98, we'd use an iterator approach, right? We'd do standard list. What is it? Line oriented connection : iterator. That's a long type name. We'll call it connection. It starts at mconnections.begin, and it continues until mconnections.end, and we increment it every loop. And then this would be the arrow operator, so we do the indirection through the iterator to get to the connection. Okay, so this would be a C++98 approach, and it's still perfectly legitimate here. There's no loss of efficiency or anything like that, but there are a couple syntactic nicenesses that we can take advantage of here. First, we already know about is the auto keyword. So if I use auto connection, right? So this is declaring a value type that's deduced from mconnections.begin. So it'd be the iterator type without all that long type name. And it would be the right iterator type. I wouldn't have a chance of misspelling or doing something that gets casted to implicitly or something like that. So that's where auto comes in handily. But actually, in C++11, there's one more improvement to this, which is we can do what's called a range-based for loop. Rather than spelling out how you increment through this loop, we could just say, do everything in the list. So that would look like this. We'd say for auto connection in mconnections. And as long as mconnections is a type that is a container, so I'm not exactly sure of the specific requirements, but every STL container will work. I imagine if it has a begin and an end, it probably ought to work. But yeah, just use the STL containers. Don't write your own container classes. So we'd say for every connection in the connections. Okay, let's get rid of this. Now, one small difference here. Connection is no longer an iterator. Connection is the actual type of connection. So we'd have to do dot here, but more important than that, this is a value type, right? So we're actually copying for every connection from the connections. So we're sort of creating our own local loop variable here by copying, and connections can't be copied. And we don't even want to copy connections. So we do it by reference. And this is what it looks like. This is what the final loop looks like. We say for every reference to a connection in the connections, close the connection. Looks very nice, very easy to do. And you're going to see this a lot in C++11. Range-based for loops are a very nice syntactical feature. And it's exactly as efficient as walking through an iterator. So don't not do it because of efficiency concerns. The one reason you might not be able to use a range-based for loop is if you have logic that's maybe a little too clever and it needs to manipulate the iterator, move it back or forward or something like that based on logic in the loop, then you still have to explicitly get an iterator. But if you're just doing a regular loop over all the things, then this is how you do it. All right, so next we got to look at what's connection.close. That method doesn't exist yet. So connection.hpp. Let's make it. So void close, right? Now, we want to take advantage of the logic we already have. We want to tell the reader class, the derived class, to wrap up and to call, so to kill any outstanding async read, and to call the done reading method. So to interrupt any of its pending async reads, we have to do a socket shutdown. That'll get the IO service to kill the async read, to tell it, hey, you've been operation aborted, and then that'll cause the error handling clause in the line-oriented connection class to call done reading. So to do that, we'll shut down the socket. We'll do shutdown, and we have a choice here. We could do this. But also, because this is a TCP socket, we have the ability to shut down one side of the connection. We can shut down for reading or shut down for writing, or both. And in this case, that gives us the advantage to cleanly shut down, to purge all of our outstanding writes by only shutting down the reading side. So if I do, what is this, shutdown receive, I think this is right, then we'll stop receiving and all of the async reads will return, but the async writes will get to finish. And we can even do any last writes after this, like to tell the client goodbye or disconnected because server was shut down for reason X, something like that, which makes this much more friendly. All right, so if we do this, we do shutdown receive. Then let's walk through the logic real quick. We go to line-oriented connection. This async read until will come back with an error. It'll be operation aborted, or maybe there's a more specific one for shutdown, but something along those lines. And we'll get that async read until encountered an error, and it'll call done reading. And then the connection will delete itself, and we're happy. And so this will happen to every connection when we run that for loop. That'll get rid of all the connections, and then we've canceled the acceptor. We've canceled the signal handler. So that should be everything in the IO service, and the IO service should return. So this should work. Let's compile it. Okay. And the way we're going to test this, we're gonna run the mud, and we're going to telnet into it, 5,000. And we're going to leave this open. So we know when we close the connection, we go back over here, it would delete the connection, right? The connection would delete itself when it's done. But if we don't do it from the client side, if we leave it open and now try to do Control-C, let's see what happens. Let's just create some lines there. All right, so we got the signal. And then we got that async read until encountered an error. So we did the socket shutdown, which caused that to return. And then when it returned, deleted the connection. All right, we're happy. So that was the last thing we had to do logically. I have a couple formatting changes I want to do before we move on. We'll try to do these real quick in the last part of this part. I want to change connection to connection base. This is just a naming convention thing for me. Since we introduced the derived class, line-oriented connection, we really need a superclass because connection on its own was just doing writing and closing, and that doesn't make any sense on its own. You can't have a connection that only does writing and doesn't do reading. And in fact, to reflect that fact, I'm going to move the constructor into protected. So you have to inherit from this. You have to implement reading. Okay, so we'll do that. Connection base, we're calling it now. So naming convention wise, I like base for like a partially implemented class. But then if it's not implemented at all, if it's entirely virtual functions, I like to use like iConnection, something like that. It's sort of a more Java-like naming. Let's go to line-oriented connection. This is going to be connection base. This is going to be connection base, and so is this. All right. So I just want to kill those files and move them. Let's go over here to the server, move connection to connection base, move connection to connection base, and then let's update the make list, connection base. Does this compile? Missed one place. We missed the... okay. In connection base.cpp, we have to include connection base.hpp. Okay. All right, great. That compiles. Now, there's one other cleanup thing I want to do. Let's look at server.hpp. This is getting pretty crowded here. I really should have moved some of this into a CPP earlier. I know I said I like to start in an HPP and allow things to inline if possible. But a lot of this isn't going to get inlined, and we really, if it's going to be compiled code, we should speed up our compile times and only compile it once. So let's see, using namespace, mud server, okay. And let's bring down, before we do that, I do want to move, there's this signal set async wait here. I actually want to do that in run because I want to make sure it gets called every time we run the server. Now that we have the ability to shut down the server, I want to make sure we could say server.shutdown, server.run, and toggle between those two states. And every time we block, we really need some listener to help unblock us. So I want to do that in run instead of in the constructor. So it happens every time we run. Okay. Now let's finish up this cleanup. Let's move all of this, run, shutdown, and accept, I think. Let's move this down into here. Server, run, Let's make sure we get our indent levels right. Server shutdown. And server accept. Okay, that looks good. And let's go back to server.hpp. We could put private back here. And we have to define accept and run and shut down. Okay, let's see if this compiles. No, one more thing. We have to go back to our make list and add server.cpp in here. Let's see if this compiles. We have to include IOStream. All right, well, this was part 10. My name is Ken, and thank you for watching.